the feedback link is provided into the WhatsApp group, and then we can continue with the session. Okay, now as we reassemble after a short break, it gives me immense pleasure to welcome you all once again on the ongoing faculty development program on the title of Towards Sustainability, the Role of Advanced Materials in Next Generation Engineering. Now, as we move on the session 4, and we are deeply honored to have with us once again our distinguished resource person, Professor Om Prakash sir from Department of Mechanical Engineering, NIT Patna. Professor Om Prakash sir is a renowned academician and researcher widely recognized for his extensive work in renewable energy systems, sustainable fuels, and advanced materials. His research contributions in the area of clean and efficient energy technologies have been highly impactful in addressing the challenges of the modern society systems. In the session, in this ongoing to be session, Professor Om Prakash sir will be speaking on the topic of bioethanol from the indigenous resources, a sustainable alternative fuel for the IC engines. And this is a subject of immense importance as the world continues to seek eco-friendly and economically viable alternatives to the conventional fossil fuels. The discussion will explore the potential of bioethanol as a renewable energy source and its production from indigenous materials and its applicability in internal combustion engines to promote sustainability. So let us all extend a warm welcome to Professor Om Prakash sir and look forward to an insightful and inspiring session ahead. Thank you, sir. And now I'm requesting Om Prakash sir to take over the platform. Thank you, sir.
Hello, can you hear me?
Yes, sir.
Yes, very nice. Anuj, I am Professor Om Prakash. I am a delivering lecture and bioethanol from indigenous sources, a sustainable alternative fuel for internal combustion engine. I think everyone is able to see my slide
Yes, sir.
and you are able to hear me.
Yes, sir.
Now see, uh, in this program toward the sustainability, the role of advanced material in the next generation engineering, I am very glad to uh, uh, give this lecture that is having the bioethanol, which are my basic things. Now, if you are saying in general description, why, what is the, why this thing is coming in that. So where we have to see what is the available thing was there. That was the conventional fuel was available. And this conventional fuel like coal, diesel, gasoline, CNG, etc. it was there. If you know the quality of energy in that, approximately the coal, diesel, gasoline, CNG, this all around 40,000 kilowatt, approximately 40,000 to around 45, 46,000 kilowatt, kilo, kilojoule per kg. So that means here, if you are seeing this energy contains, it is very, very high. And if you see around 72% transportation fuel demands fulfilled by the diesel alone. But if you will see that 23, when later on CNG came, the transportation demand in fulfilled by petrol and rest of CNG. The government of India, now if you are seeing in 2022, India is decided to reduce the import of the crude oil by 10%. By and another challenge is there, by doing this thing, we are producing a lot of NOx, sulfur dioxide, carbon dioxide, CO, HC, and particulate matter, etc. So what is there? One, that means we are challenging here two way. One challenge is here. What is there? Another one challenge is here. We are depleting our conventional fuel reserve. Another challenge is there. We are increasing the our demand for the conventional fuel. So what? How we can able to meet? That is the challenge. So we are looking here. So the alternative fuels, in this alternative fuels, if you will find, that is the biofuel is there, biodiesel is there, bioethanol and bioethane and biomass, etc. That is there. Another one is a hydrogen fuel. Now this thing, when it is coming, then if you are seeing here the biofuel, the derived from the biomass such as the plant animal waste and the agricultural waste and by microalgae. Here you are seeing that if you are using the biofuel, so if you are seeing the sustainability point of view, then sustainability point of view, if you are seeing, then you will see here is that sustainability means if you are seeing the coal, that is taking the millions of years for the generation. But here, if you are seeing the biofuel, so this is the, if you are taking the biomass, plant, animal waste, and other things, this is hardly 1 year, 2 year, 3 years. Sometimes you are finding that is a six month itself. That means here renewability of the uh, fuel or a biofuel is a very sustainable. Another thing, if you are seeing at the price of fossil fuel, then it is rising, and then it contains a biofuel cost effective or also environment friendly. That means that is the environmentally it will be sustainable, and that's why we are going for that. A substitute, that means from that some part, if you are taking from the biofuel, and then we are our reservoir, what is the reserve fuel is there, that will be reducing, and finally you will find, we will find, so somewhere we are able to meet the our requirement, growing requirement. Now if you are seeing, what is my topic is there, ethanol. That is, a ethanol is a clear and colorless liquid produced by the sugars such as sugar cane, sugar beet, and starch. And ethanol blending with the fuel improves the performance of internal combustion engine also. And how ethanol is being produced, if you are seeing the ethanol, so there is a first generation, second generation, and third generation. Nowadays we are moving with that second generation and third generation. If you are seeing the first generation, in first generation you will see the sugar cane, sugar beet, starch, wheat, potato, barley, corn, etc. is being used, and from there ethanol is being produced. If you will see the second generation here, in second generation normally we are seeing the wheat straw, linguistic, and the rice husk, wood grass, forestry waste. What is the waste is there, that is used. But third generation, if you will see, then you will be finding the microalgae and seaweeds that is being used for the production of ethanol. So now these are the sources by which we can able to produce the ethanol. Now next, if you will see the alcohol, what is the ethanol? Ethanol basically is alcohol. Alcohol are the alternative, attractive alternative fuel, because they can be obtained from the number of sources, both from natural and manufactured way. And here, if you all see, the methanol and ethanol are the two kinds of alcohol that seems most promising and have had a most development in the engine fuel. Now you see the advantage. We have to see finally, if you are doing something and somewhere, so whatever the research we have done, our ancestor had done, there we have to see what are the advantages there and why we will go for that mass production, or we will going to increase the things. So first thing, if you are saying can be obtained from the number of sources, and that will be naturally manufactured. And second thing, it is having the high octane number. That means this is the anti-knock index number, which is octane is providing. It is over 100. That means a very good fuel. Another thing is a high octane number results high flame speed, so that the time for the combustion that will be reducing. Next thing, if you are seeing the engines using the high octane fuel can have more efficiently by using the higher compression ratio. If you are we all are knowing, as the compression ratio is increasing, we are having more work done. And that's why if you are increasing the octane, this compression ratio, then another advantage is there in the combustion side. And that combustion side advantage we are getting, get rid of that if you are using the high octane number. Now next thing, if you are generally less overall emission, if you are seeing whatever the research we have done in that point of view, when compared with the gasoline, then when it is burned, it far more moles of exhaust, and which gives the higher pressure and more power in the expansion stroke, because the compression ratio is higher. And that's why if compression ratio is there, then expansion stroke will be higher, and then you will be getting the more power. Has high evaporative cooling. That means, see, if you are seeing when the fuel is coming inside the engine, if I think all of you are knowing about this, when it is coming and evaporation is taking place, so that evaporation means when it is evaporating, the heat is taken from the air itself. So whatever the air and fuel, it is mixing and it is going inside the combustion chamber. Then what will be happening when this will be having that, when evaporation is taking place, then a lot of heat from the air that is taking out, taking for the evaporation, and then the temperature is reduced. When temperature will be reduced, then what will be happening? Then you are seeing the more density will be there, and because of that, it will be having the more, uh, that is the volumetric efficiency. So that if you will see, the because of the high evaporative cooling, this result cooler intake process, and that's raised the volumetric efficiency of engine and reduce the required work input for the compression stroke. Another thing, if you are finding here, that is the low sulfur contents in this fuel. So these are advantage what you are seeing. And then we are seeing, after seeing this advantage, what is the world where it is moving. If you are seeing worldwide fuel ethanol production in 2021, what is available in that, if you are seeing the United States itself is producing the ethanol, this is in, the figure is million of gallons. So you will see here around 15,000 million of gallon. Whereas Brazil, if you are seeing, the Brazil is having 7,500. And if you see India, where we are already, the first discussion, we have already discussed a lot of solar energy is there in our countries, and the result is a lot of vegetation is also there. But whereas we are seeing the India around, we are producing around 820 millions of gallon ethanol, but presently we have gone for the double approximately now in 2025. That's why E20 we are using at present. So that a lot of opportunity there, that opportunity make us to think of here what way and how we can able to increase the production of ethanol, and that can be used. So now you will see here a typical flow diagram what I am showing you. The flow diagram for production of ethanol, if you are seeing from the sugar cane, it will be grinding, and then fermentation is taking place. After fermentation, keeping for that certain time, then distillation is taking place. After distillation, we are going for the ethanol. This is the first generation. If you are saying in the second generation production, Then whatever the corn and other thing is there, that will be first, it will be milling process will be done. And then enzymatic hydrolysis we are doing. Why we are doing enzymatic hydrolysis? So that that can be with enzymes, it will be broken into the smaller one, and then only fermentation will be happening. Then finally distillation, and then we are, from the distillation we are producing ethanol. Then next thing, if it is a third generation we are seeing, so I am discussing either here with the third generation. If rice husk is there, that is the waste is there, and that waste can be can be grind, and then after grinding, what is there? Again, we are one more process we are adding, and that process is pre-treatment, pre-treating that one. After pre-treatment, again we are breaking into the smaller one, then we are producing the cellulose conservation, that is hydrolysis. After hydrolysis, then we are again going for the fermentation, and then next process is distillation, and then we are producing the ethanol. Now, if you are seeing here, you see a beautiful things I am showing from the slide, which already being produced. The feedstock is there, and then it is the pre-treated. It is grinded one, and then it is a pre-treated. After pre-treatment, you can see in the slide what is the color is there. This was produced from in by my one student here at my NIT itself, and there this all photograph is being taken at that place. So now physically, the physical pre-treatment you are seeing. After physical pre-treatment, you can see here chemical pre-treatment is taking place. Then we are adding the enzymes here. Enzymatic hydrolysis we have done, and then fermentation is taking place. And you can see from the slide itself the how fermentation is taking place here at this place. And then you see here distillation process for purification, and then finally, hello, then finally you can see here the ethanol is produced, and you can see the ethanol. What is the that means ethanol color here? You can see. Now next slide you can see here ethanol production. What is the main things by rice husk? The if you are seeing the main thing, what is the resource is available through the resource. If you will seeing the rice husk is a agricultural by waste which is available in abundant at the low cost. Next, if you will seeing the beauty of this resource, that is the rice husk contains cellulose and hemicellulose. Then around 670 to 750 millions of ton of rice husk is produced worldwide every year. And India is the second largest paddy production country in the world. You can think of what is the our that is the what is the our basic things and where we are lying. What is the sources is there. So India, you can see is the second largest producing country here. And if you are seeing here in the figure, millions of ton versus the what are the countries are there, that is again one more we have shown from this. And directorate for the economics and distillate statistics, there if you are seeing the millions, the production of India in million ton, what is the rice is there, then you can see here we are still growing very fast. Now, next thing, the comparison of properties of different fuels. If you are because I have told you the ethanol, how ethanol is there, then we have to see what are the, how we are comparing this ethanol to the other, what fuel we are using, like gasoline, diesel, and other. Basically, these are the fuel which is being used. If you are seeing the octane number, so gasoline approximately it is having 90 to 100, octane number 98, 97 like this is there. But if you are seeing the ethanol, it is having 108 octane number. And I know most of you are knowing the octane number. What is the octane number? And I have discussed the higher octane number. That's give a very good higher compression ratio. We can go for that, and we can produce that is the high expansion. Then if you are seeing the C10 number, the gasoline having around very, because the gasoline don't we are not seeing that in the C10 number. It is just reverse of that you are seeing. So diesel is having around 40 to 50% this C10 number, and that methanol, ethanol, it's not bothersome of that. The calorific value, second very important thing, which is given here in megajoule per kg. If you are seeing the gasoline, around 43 megajoule per kg it is there. If you are going into the kilojoule per kg, then it will be 43,000 kilojoule per kg. Whereas diesel, if you are seeing approximately same range, around 44.65, that is the megajoule per kg. And if you see the ethanol, approximately you will find around 30. That means one third of that. Methanol is still approximately half of that. Around 20 it is there, 20 megajoule per kg. So you will see here the major thing, major what we are seeing the difference, that is the calorific value, and that calorific value it is having approximately half of that. Then enthalpy of vaporization, as I discussed here, you see it is a kilojoule per kg, that is a 348 kilojoule per kg enthalpy of vaporization is there for gasoline. Whereas the diesel, if you are find certainly some more it is a vaporization, enthalpy of vaporization is required. But if you are seeing here ethanol and methanol, that is a 790. That means we are comparing here with this gasoline, then you will finding slightly more this kilojoule per kg vaporization, that is the heat of vaporization is required. If you are seeing the density, so density is approximately you are seeing the same value, around 730.8. Around gasoline it is having that the different temperature, whereas the 790 we are having the ethanol, and 796 we are having. If you are seeing the another very important property, viscosity, you will find here the viscosity is more in the case of ethanol in compare with the gasoline and diesel. Another very important property, that is boiling point. If you are seeing the boiling point, you will see here the boiling point is approximately it is having 78.5 ethanol, and whereas methanol is having around 65. Whereas the boiling point for gasoline around it is having around 30 degrees centigrade. And another is a flash point. Flash point is another very important property for the all fuels. I think you all are knowing what is the flash point is there. So flash point, if you are seeing that is the flash point is a for ethanol, it is a lesser than diesel, but it is a higher than the gasoline. Auto ignition temperature, that's another very important point. Through that we are seeing that how much energy is being given before ignition itself. That means then in that case you are finding around 257 gasoline, that is degree centigrade, whereas diesel is having 315, that is auto ignition temperature, and whereas ethanol is having 422 approximately, and 463. That means that is the auto ignition temperature is higher. And you know the auto ignition is a very important role is playing. The stoichiometric air fuel ratio, if you are seeing around gasoline having 15 point, that means air fuel ratio means per unit fuel how much air is required. So that is the air fuel ratio, and that air fuel ratio, if you are seeing here, the ethanol is having approximately half of that, around 6.46, whereas the methanol is having 8.96. So by this data, what is the very important data, and that we have created mostly ethanol what we have produced, that we have measured also. So that was we have find in the same range here. So this property, why it is required, so that we can see what is the compatibility of that fuel is there, about which we are discussing. So that's why you will see the compatibility of this ethanol. Now next thing, if you are seeing the production of ethanol, then here you see around a billion of liter per year. Then United States, how much it is there, and India is how much it is producing. So if you are from this figure, one can able to see ethanol production in billion per liter, billion liter, and year wise. This what data is available here around 2017 up to, and that's why this is the how it is increasing trend of increment of the production of ethanol is there. Now seeing if you are seeing yes, whatever the state of art is there, in that case how it is going for the production. So through that we came to know what is the opportunity is there, and what other researcher they have done it. On that basis we have formatted and we have seen. If you are seeing the experimental setup for which we are going for that, because this is the very important, we have seen that is the compatible things is there, and then we have seen yes, whatever the property is there, that property is meeting. Another very important point we have seen, whatever the our that means storage is there, that means availability or source are there, that source itself is a very high. Then what another thing is there, how we can produce. So if you will see here the experimental setup what we are utilizing for the production of this ethanol. So now you can see at the, because this all things we have seen in the our lab, and this all experimental setup is produced here itself by the our team member, or you can say by our students. So you can see very easily from the photograph itself how we are going for the production of this. You can see this is the one heater is there, and that heater we are producing heating here, and a pressure cooker is there. And with this pressure cooker, whatever this rice husk, that was a mix, and then it is being pre-treated here. After pre-treatment, if we are seeing the burette, by burette we are putting some amount of pre-treatment for that, and then by the boiler vessels are there, and hot plate is there. You are seeing this hot plate, and this hot plate is being created here, and it is a heating again, so that whatever the things is coming out, that again we can go for that production. And you can see here the condensed material what is there, that we are taking out here in the beaker itself, and whatever the sludge is, the rest sludge is already there in the cooker itself. So through that a very small experimental setup is being created here, and that creation of experimental setup is here very simple, and whatever the local thing is available, from that we have created this experimental setup for the production of ethanol. Now next thing, if you are seeing here the what are the component is there, and how we are because the important thing is there ki how much we are going for that, what are the measuring instrument we are using, and what are the component how we are produced. So now you can see the made of GI sheet here. This is the all dimension is given here, and through that dimension the experiment is taken place. The experimental. Now you can say the condenser how we will produce. Now everything's here. If you are seeing the whatever things I am showing here, the everything is being done here at the college level itself by the students itself. So now you can see the condenser how they have produced the copper tube around 3 meter length we have taken, so that we can having the coiling itself, and vessels which is having around 35 centimeter, and the diameter is around 25.4 centimeter. Through that you can see the coiling is done, and that coiling is being put here in the pot, which is having around 35 centimeter and diameter is around 25.5 centimeter. And then you can see here the pH measurement, because the pH is very important for the pre-treatment, and then the fermentation it is required, so that until unless that pH is not maintained, the fermentation will not take place. Or if fermentation will be taking place, then also that will be the smaller quantity. So if you will see the range here, whatever the measuring instrument we have taken, so that about the measuring instrument it is given, what is the dimension is there, what is the weight is there, because the measuring instrument is one of the very important thing for production of that measuring the quantity. So that's why it is a important thing, and we have to specify that one. Now next thing, if you are seeing the calibration of pH meter is also being done, because we have to check what is what are the instrument we are using, and that instrument is whether it is a giving the correct reading or not. So for checking the correction here, calibration of the instrument is very important. For the calibration purpose, you can see here the calibration with the with the buffer solution of the PS7 we have taken, because it is already fixed, and through that we have checked and found it's correct. If any mistake is there or any deviation is there, then deviation we can write down. Then another checking, we have done the calibration by buffer solution of pH 4.1 for the acidic region, and that also we have noted down. Then again checking with the calibration for the buffer solution with the pH 9.2 for the alkaline region. That means this range itself is a showing if we are checking with like different range, so we will be finding if any deviation is there, that deviation can be added whatever the your exact reading we are getting from that during our measurement. So it is very important point for the calibration. If any things we are taking for the purpose of the uh, measurement. Now next thing, if you are seeing the hot plate is there, and that is specification you can see here very easily. This is the around 1250 watt we have taken, and voltage that much hazard, and here burette we have taken that also 50 ml. And why burette is there, so that we can whatever the quantity of this pre-treatment enzymes that we can put it in this, and that will be exact measurement should be there. Now if you see induction here, that also we have specified the all inductions in which the weighing machine also, that weighing machine approximately you can see around 0.001 gram accuracy is there. And whereas you can see the voltage around variation of temperature, if you are selecting in that case for the heating instrument, that is approximately 60 degree to 250 degree. And variable power selection we can do for the 120 watt to 1600 watt. These are very important parameters when you are going for the experimental work, so that how much variation we can able to take. If you will see the here the high temperature thermometer, what is the approximately the temperature is and accuracy, how much it is there. There approximately you can say if you are measuring minus 20 to minus 50 degree centigrade, in that case plus minus 2 degree ka that variation is there. And around minus 20 to 200 degree centigrade around one. And here as if for going again for the higher range, the around 200 degree to 300 degree centigrade, you can see the plus minus 2 degree of variation. From this you can see why what is the important of calibration is there. Then another LCD digital thermometer we have used, and that also the temperature range is minus 50 to 110 degree centigrade, and accuracy is around plus around 2.5 degree centigrade to 1 degree centigrade. Now next, if you are seeing the chemical what are the used for the pre-treatments for and enzymic treatment, the sodium hydroxide we have used, that is the and sulfuric acid, yeast extract we have used, and peptone and dextrose that is being used for this uh, uh, treatment process. And now you can see here the preparation, how we are prepare that NaOH solution. That also it is given, so that you can come to know what solution. If it is a zero point 0.1 m solution is there, then how much dilution is required, and which way we have to dilute. And that's why the sodium chloride, what is the we have prepared here for one more m 1 m solution, to if you are going for the 0.1 solution, then how your dilution will be there, and that is being given here. Now if you are seeing the first day what we have to do, we have done here. This is the rice husk we have taken, and this is being crushed with the laboratory hammer. Now you should see here, by hammering it is being crushed. Around 500-gram rice husk is taken, and that was the pre-treatment we have done to increase the biodegradability of the biomass. So that we have done for the pre-treatment, that is a physical treatment. What is the steam explosion? That means steam is being fed inside, so that it will be having the slightly, it will be loosen the things. Then acidic treatment we have done for sulfuric acid, and then alkaline treatment we have done for sodium hydroxide. And this all treatment, after treatment, you can see we have measured the this physical treatment, steam explosion, by which you have seen that one boiler we have taken. From the boiler the steam is being produced, and that steam is being treated, given for treatment. The dilution around, how much time we have gone for that? Around 45 minutes we have gone for that. Then acidic treatment, if you are a pre-treatment you are seeing, then H2SO4 we have gone for that, and required pH is 5.2, and quantity around 250 ml, and balance we have done that. And heating around 90 degrees to 100 degrees for 2 hours we have heated. And then you can see here, by balancing the table here, you see the quantity of sulfuric acid and equivalent pH that is given in the table. And from that table, one can visually see 50 ml, 100 ml, 150 ml. That means different of the 50 ml. When we have done, then what is the equivalent pH we have got it. And then you can see here the alkaline treatment. After that, what is there? If will solution sodium hydroxide, you can see from the burette how the it is being mixed here, so that we can increase the pH of the 8.2, and 50 ml NaOH is used for the burette, and then it is going for the treating the 90 degree to 100 degree for 1.5 hours, and substrate is leaves for the cooling at the room temperature slowly. So that means why we are going for the cooling, so that we can beat the treatment. After treatment, it will be having that normal temperature, and then finally we can go for the enzymatic hydrolysis. So for enzymatic hydrolysis, you can say a breaking cellulose, for the breaking cellulose and hemicellulose into the simple sugar. That's why enzymatic hydrolysis is being done. Amyls with the fungal diastasis is being used here. The quantity approximately what is being used here for the 5 kg, that is the 0.5 gram per liter we have used. Around 1.8 gram dissolved in 250 ml of conical flask, and mixed with the previous substrate. And then we got the pH around 4.2 by adding some more H2SO4, and that is approximately 50 ml we have added. And through that heating 80 degree to 90 degree for 45 minutes, and then solution is incubated for around 24 hours. Why 24 hours we have incubated? So that the enzymes enzymatic treatment can be completed. Otherwise it takes the time, and that time is we have given here. And this here again I am adding here, during my experiment what we have done here at this stage, it is around 25 hours. So further, if you are going for the next treatment here, so we can see whatever the things we are varying here, varying the quantity here, the pH or whatever the other things when we are varying, in that case, how we can reduce the enzymatic treatment time, that is a incubated time from the 24-hour to again we can reduce a smaller one. So by doing the different at the different temperature and different uh, treating way, the quantity we can see, and that's why this experiment has been done in that uh, to find out that. And then next is a fermentation, the biochemical process to convert the glucose into the alcohol. That is the fermentation is taking place for longer time, and that is anaerobic process. And fermentation media is a yeast extract around 1%, and glucose is 1.5% we have taken. For the 30-gram yeast and 45-gram glucose is dissolved into 100 ml 100 ml of metering cylinder, and then it is being kept. For that, the fermentation vessels is sealed with the insulating tabs so that there should not be any air should pass inside, because this is the treatment is anaerobic treatment, so air should not be passed, and that's why we have closed so that we can prevent the leakage into the vessels. The pH, what is adjusted here, that is approximately 5.8 by adding the 100 ml more H2SO4. It takes around 3 days to complete the fermentation. Again, you see, here again, as a researcher, we have to see the fermentation is taking place 3 hours, 3 days, and whereas you are seeing the enzymatic treatment, we are going for here 24 hours. So that means here the both process is a lot of we have to change a lot and see how we can reduce the fermentation time, along with the how we can reduce the enzymatic time. So this is again by varying the different quantity we have taken, and by that varying that quantity, and that will be producing the lesser time, and that lesser time will be making you the production process is more that is the more simple, and that can be increased. So that's why this all variation is required. Now if you will see the atmospheric temperature variation during the fermentation time, what is the 3 days we have kept for the third, fourth, and fifth day. So now you can see every time and the temperature is measured, and the temperature at time, the diagram what it is there during the day fermentation, because we can see the fermentation how it will be depend upon the temperature. Now if you will see the result first experiment, we do not get satisfactory result after fermentation, and major reason behind this we find we do not use proper fermentation media. Next, you can see the fermentation does not occur properly because vessels open early. That means if vessel is early open, that's why we are not able to take out that things. And if it is a that because of the experiment we have got it, if which way this will be happening. So then distillation is accomplished by the simple insulation vessels, therefore leakage of the vapor that is happening, and that should not happen, and that to be covered very easily. So from that first experiment, these are the result we have got, and then this result, these are the result we have implemented into the second experiment. And this second experiment, if you will see here, the preparation of biomass rice husk cleaning and dries in the sunlight, and then rice husk is melted to the floor milling. Earlier we have gone for that just by the hammering one, and that second experiment was we have done again for the crushing that one and this milling, so that it will be again some more smaller particles. So 1 kg rice husk and powder that has been taken and that has been taken for that husk powder is taken for the experimental purpose. Now see, you can see here the milling machine is there. That is the machine is there, and this machine we have put in this rice husk, and then we have milled, and so that it will be having the smaller part, smaller one. And now you can see before milling and after milling what is the result is there. This is before milling what we have done in first experiment, and second experiment when we have see that is the after milling, you can see here what is the result is there. Further it is broken into the smaller one. So now second day, if you see the pre-treatment for 1 kg rice husk we have taken, and physical treatment we have done for 99 degrees centigrade steam explosion. Now you can see how the steam is being fed into that, and solution of rice husk is made to added in 3 liter distillate water, and then acidic treatment for H2SO4, what is the milling for the around 95 to 100 degrees centigrade, around it is 1 hour. Then alkaline treatment again we have done. We have performed here around 45 ml, and that pH is 7.3. Heating again we have gone for the 95 to 100 degrees centigrade for 1 hour. And then you see here the third day enzymatic hydrolysis when we have done. Then you see that is 1 gram per liter we have put here, and 4 gram dissolved in 250 ml conical flask, and that will be done here. So that solution is heated for 80 to 90 degree for 40 for the period of around 45 minutes, and then pH you got it around 5.5 by maintaining adding the H2SO4. So solution is incubated for the 45 hours, and then you can see here the fermentation for the 4 days. We are putting the for fermentation the yeast, peptone and glucose. That is the three things we have put it in this, and total solution is being prepared for the 3 liter, and that will be describing the temperature of fermentation around 37 degree. We have kept it here, and the pH is again maintained around 5.6 by adding the again 100 ml H2SO4. Now you can see what are things we have put it like yeast, peptone and glucose. This all thing is measured here, and then we have added in that solution. And then you can see here atmospheric temperature is maintained, and then again you see the variation of the temperature for the day that is measured. And here you will find the temperature variation is slightly more, and here the 8 days, days 1, days 5 and days 6 and days 9, you see 5, 6, 7, 8 and 9 days that is being observed here, and this observation make us the things. Now you can say the 11th day after doing this fermentation, then distillation is being taken, and that distillation is done by using the pressure cooker here. A slurry is obtained. Now you can see the from the experimental setup here. A slurry is obtained after fermentation is filtered using the cloth and sieve, and then 2.5 liter approximately fermented solution we have had. We have got it this. We have obtained. Now from the 22.5 liter fermentation solution, the boiling of ethanol around 78.5 degrees centigrade. Therefore, we maintain around 80 degrees centigrade temperature very easily, and takes around 4 hours to complete the distillation. And after distillation, you can see here the ethanol recovery. That's a very important thing. So see, ethanol recovery is there. But how much duration is there? How much ethanol we have recovered? So time, if you are seeing here, throughout that time we have taken, and around 400 ml we have got it the ethanol. And from the experimental setup, you can see how the ethanol is being produced. In one beaker, you can see here the beaker is there where ethanol is being collected at this after the this distillation. Now, if you see experiment third experiment, what we have done, we have taken around pre-treating around 100 grams of milled rice husk. Then physical treatment we have done for around 99 degree for 1 hour. Then acetic and pre-treatment we have done for 3 liter around solution we have prepared, and that is the around you can see H2SO4 is being put, and then alkaline pre-treatment is also is being done around 7.3%, adding the 30 ml of that. And then the third day enzymatic treatment, and that 2 liter solution and 2 grams amyls is being put in that. And through that, if you are seeing here again, the fermentation is done the similar manner what we have already discussed for the same. And then you can see while distillating the things, you can see the color here, what is the change of whatever the thing we can observe here, that easily you can able to observe from that experimental, that experiment what we have done, and the next experiment what we have done. In that, in this time we are using the induction heating for the placing the hot plate, and better temperature control we can able to do in this. And pH is maintained around 4.3. The process temperature around 79 to 82 degrees centigrade we have done, and around 1.5 liter total filtered solution we have taken, and this we have seen. And by that, after taking out the separation, and then ethanol recovery, if you are seeing, that is much slightly we have increased the ethanol recovery around 140 ml, and the time is smaller time it has taken. So that means here, if you are seeing that now we have seen different, we have used, these are the process by which we are produce the ethanol. That means preparation of ethanol it is there, production of ethanol we have done, and many 2 3 experiments, some more experiment we have to go, so that some we have to see how much recovery we can able to do by doing this experimental work. And that's why I am showing you all how the we have to perform these are experiments, so that you can see what is the which variation, by varying what things, what is the result is coming. Because most of things, until unless it will be not done in laboratory, then you cannot go for that when production process. So you have to see ki we have to increase the production, and what are the effect is there, that effect we have to observe. That is the important thing. Another thing is there, after doing these things, then we have to go for the engine testing. So now, whatever ethanol we have produced, the same ethanol we have used here, ki how the performance of our engine is done. Hello, are you able to listen? Hello, hello. Yes, please. Ah, Rahul. Hello. How much time is left?
Yes, sir.
How much
15
time
minutes,
is
sir.
left?
15 minutes, sir.
Okay. So that's why I am going for the next one.
Okay, sir.
So now you can see here the engine testing setup. You can see this is again in laboratory. It is established, and you can see how this all experiment is being uh, that is being set up at the laboratory by the student itself. It is you don't think that these are instrument is being purchased from the one that is vendor, and that is being they have put it. This all thing is being prepared here itself, and by students they have fitted this all things. So you can see very easily in the testing setup, if this engine is Kirloskar engine, and there you can see here this all burette, prepare, and other things, whatever the pipelines are there, and another thing is there. That's all is being uh, uh, this all being put it at the board by the students. research student. And now you can see by measuring the power here, the another thing is being prepared. That is, you can see this is indigenous. By the we are measuring here the power, not the not the governor or other things. Not the this means that is the uh, uh, belt dynamometer or other things. It is being measured by the electrical power itself, the load panel that we have it is there. Then you can see here the performance parameters for analysis, how we are analyzing that mass flow rate of the fuel, and then we have through that we can have the brake specific fuel consumption we can calculate, and the brake thermal efficiency also we can able to calculate. Now the mass flow rate, how we are able to calculate by the air, and that is a formula is given, and that is it is known formula for that, everyone is knowing. And how the air fuel ratio is calculated, because the air fuel ratio for the mass of air and mass of fuel is required, and that all is being measured, and that's why very easily it can be calculated here. Now you will see the result here, mass flow rate of the fuel versus load. Then you can see here ki what a beautiful curve you are getting, the mass flow rate of the fuel, that is a kg per hour. And here you can see the load, what is the load we are putting on that. So you see the ethanol, that is the zero. If that means we are not putting the any ethanol, in that case, what is the performance is there? And when you are putting the ethanol around it, this is being tested here for the 5%, 10%, 15%, 20%, and 25%. We have mixed it, and that you can see the performance here. And you one of these, you can ask why you are going for the 25%. So now you can see from the 25%, if you are going for a mixture here, ethanol, you can see the curve here. That curve it is itself is showing the mass flow rate is when you are seeing the mass flow rate is reduced here when you are going for the higher load of that. And then you can see here again the mass flow rate of the fuel versus load. You can see here which way the load is increasing. If you are load is increasing, the mass flow rate of the fuel is also increasing. And the pattern, what is the pattern is there, and that's why we have gone for the E25 here. If you are going for the E25, E5, E05, and then E15, you are having the increasing. But when we are going for the E25, you have seen it is a decreased. So again, the brake specific fuel consumption, that is very important parameter for measuring the specific fuel. That means the fuel per unit of power generation, how much fuel it is required. So if you are seeing the load variation here, so if you are increasing the load here, you can see here the fuel brake specific fuel consumption is decreased. And that important thing is a E15 you are seeing that a specific fuel consumption here, it is that will be that is having the higher quantity. And when you are reducing the increasing the load approximately, that variation will be lower side. Here you can say the brake specific fuel consumption, when you are having that is the lower load, then it will be higher. It is a well known fact for the every engine. Now you see brake thermal efficiency, if you are saying, then brake thermal efficiency versus load, you will see here the brake thermal efficiency when you are putting approximately, you see here around E25, when you are putting that time, you are seeing that it will be the higher. And even though if you are going for the higher load around 2500 here, approximately it will be brake specific brake thermal efficiency approximately same. But after that it is reducing here. Why it is reducing? Because of that the calorific value is lower, and the air fuel ratio what we are seeing, that will be the, again it is a very low, just like a 0.5%. Mass flow rate of air versus load, that means when you are increasing the load here, the mass flow rate of air is a decreasing. And the trend of the mass flow rate of the air per kg per hour, if you are seeing, then again that measurement has been taken and that can be seen in the graph itself. Now the air fuel ratio, if you are seeing, so now you can see the air fuel ratio here, that will be having the air fuel ratio is lower than the what is the E0 is there. Then speed versus load. When we are measuring the speed and load is there, so you are increasing the load and then you are seeing the speed variation, how it is coming. Then another parameter, very important parameter, that is the exhaust gas temperature versus load. When you are increasing the load, you are seeing the exhaust gas temperature is also high. And you see, even though E25 that is having the exhaust gas temperature is the higher side, whereas the you are seeing the E05 it having the lower, and it is the seeing this exhaust gas temperature is higher, and that higher temperature it shows that is the that means it more some more utilization can be done. If you see the conclusion here from the present, what is the work is there, then ethanol is renewable and sustainable, and that can be used for that source of energy, and which alternative fuel as a fossil fuel and cheap as compared to the crude oil. The mass flow rate of the fuel increases as the load increasing, and the maximum you can go for the 2500 watt. And it can be seen from this, the blending percentage increases, the mass flow rate of the fuel is increasing due to the lower calorific and ethanol fuel. The brake specific fuel consumption alone, you are seeing around 15% ethanol blend diesel, it is having the minimum as for the seeing these things. The brake thermal efficiency of engine decreases as the ethanol percentage of the it is a decreasing, and that the lower part of that maximum diesel fuel and running with the 2500 watt load. That means with the load also the variation is there. Air fuel ratio, if you are seeing from this experiment and whatever the presentation is you are seeing, that is also very good. And exhaust gas slightly it is having higher temperature because already it is oxygen is there, and the what is called speed, because octane number is very high, in that case the flame speed is higher, and that's why it will be able to burn. So another thing, we have seen the advantage of that, but some disadvantage is also is being look into that. And that disadvantage, what are the disadvantage of the alcohol fuel is there? That is the low energy content, that's we have already discussed. And alcohol is contains oxygen such as required less air, and that is stoichiometric, so that whatever the engine here, we are testing for that engine which is used for the diesel, but it's required a special design when we are going for the higher alcoholic that ethanol. In that case, we have to slightly change the, you have to change the modification of the engine also we have done. We have to do, and that's why it is required here. Next, you can see the aldehyde formation is also there. It is also corrosive than the gasoline. Like if copper, brass, aluminum, etc. is there, in that also you will be having that disadvantage. The poor cold weather starting characteristic it is there, so that also we have to look into that. Often a small amount of a gasoline is added to alcohol fuel, which greatly improve the cold weather starting. So like this, if you are having the poor ignition characteristic, that is the in general, and that also lower flame temperature generation, because the less NOx it is there, and vapor lock and the fuel delivery system, that's again a problem is there, and that can be get rid of that by some improvement. So these are the references, if you are seeing, that is being used here for the purpose of that. And with this, I think whatever the things we are doing here, this very important thing is there. We have to now the question from your side may be coming, those who are listening that things, why we are going for the ethanol. So first thing, it is available source is here, resource is with you. So if you are going for the batch production, like nowadays we are seeing We are every houses, we are having the solar panels, and with that solar panel, we are able to cater the some energy, and with that, we can able to do these things. The similarly, whatever the small village are there, and there a lot of biomass is there. With that biomass, a lot of we are having the wastage is there, and that waste can be utilized here for production of the ethanol, and that will be at the best site we can able to produce, and easily you can able to produce and make huge of the day-to-day activities like the pumping set, tractor, and other things are there that can be used. Now, I think we have. Hello.
Yes, sir.
Huh. So I think a great opportunity is there in for the India like countries where we are importing a lot of fuel from the other countries, and whereas we are having a lot of resources. I think if any question is there with this, then we can discuss.
Yes, sir. There is a question from my side that
Uh,
I encourage my students to do project on the biodiesel generation, but
hmm.
they out of curiosity they ask me, sir, why we are looking for the biodiesel replacement, because it is the trend of the EV vehicles is on trending now. So why what are the why there is need for attempting the research on this biodiesel generation, sir?
Very nice. Good. Good. Very good question. Now you can think of here. EV is there. What EV is doing? Is the major thing here the storage. Whatever the electrical energy, that's it is a very difficult, or you can say it is not being stored. If it can be only possible way is there, that is the battery is there, isn't? So that battery, a lot of work is done in the battery, and that's why we are nowadays we are coming out. But what is the biodiesel, if you are saying, or biofuel, if you are saying, the biofuel it is already available, and whatever the bio production of the biofuel is there, that is the biomass. And when the biomass is already there, and that biomass is being produced from the this environment, and that environment is producing what is there, what it is capturing, that is the carbon dioxide capturing, and we are producing the carbon dioxide. So it will be meeting the what is the natural cycle is there, that natural cycle will be meet by this one. So that is the great advantage what we are looking, we are seeing. Are you getting my point or not?
Yes, sir.
So that is the major thing, that is a natural cycle it will be able to maintain here, whatever the part is there. Any
Okay,
other
sir.
question?
Okay, sir. Thank you,
Hello.
sir. Yes, sir. Okay. Okay, thank you, sir. And it's indeed a great honor to extend my sincere gratitude to you, sir, for delivering an exceptionally and enlightening session on the biodiesel and bioethanol from the indigenous resources, the sustainable alternative for ICE engines. And sir, your comprehensive insight into the development and application of bioethanol as a renewable fuel has provided us with a deeper understanding of how sustainable alternatives can transform the future of energy and transportation. And the clarity of the presentation, supported by the practical perspectives and the research-driven discussions, has truly enriched our knowledge and inspired further explorations in this emerging field. So, on the behalf of Department of Mechanical Engineering, the organizing committee, and all the participants of this faculty development program, I express my heartfelt appreciation for your valuable contribution and continued support, sir. Thank you once again, sir. Thank you, sir.
Thank you.
Now,
Thanks.
as we
Welcome.
come to the conclusion of the second day of the faculty development program on towards sustainability, the role of advanced materials in next generation engineering, I take this opportunity to extend my heartfelt gratitude to all our distinguished speakers and participants for making today's session truly meaningful and enriching. We begin the day with the session 3 conducted by Mr. Miraz Ahmed sir, Assistant General Manager, Business Development at Hilux Auto Electric Private Limited from Gurugram, who delivered an insightful talk on recent advancements in the automotive sector. His presentation offered valuable industrial perspective on innovation, technology integration and sustainability within the modern mobility systems. And in the session 4, we had the privilege of learning from Professor Om Prakash sir from NIT Patna, who spoke on the bioethanol generation from indigenous resources. His session highlighted the importance of renewable fuels and the indigenous resources in achieving energy sustainability. So both sessions added immense academic and practical value to this FDP, and we sincerely thank all the speakers, participants, and organization for their dedication and engagement. So with this, we formally conclude the second day of this faculty development program, and thank you all for your participation and all the participants for having such a great patience and active support for today's session. So let's call it a day. Good night and see you all tomorrow. Thank you, everyone.
Thank you.